So this is the exponential form of a number and this is a logarithmic form of a number. So when we say y is equal to a power x, then x is nothing but log y to base a. So this base may be anything. This base may be any real number. So therefore, log value of 1 to any base is always equal to 0. Log 0.01 to base 10 is equal to minus 2. So this can be written as 10 to the power minus 2 is equal to 0.01. Hello everyone, a warm welcome to one and all. This is your Shruti ma'am lecturing in Vidhyaashram, the Temple of Excellence, Mysuru. In this session, we'll take up the new chapter number 4, Logarithm. So let us see the weightage of this chapter for your examination. In this chapter, you will be getting one multiple choice question and one long answer, that is for 5 marks, overall 6 marks from this chapter. So evaluation of logarithms plays very important role in this chapter here. Now here in this session, we'll be studying what are logarithms and we will study the laws of logarithms. So logarithms is another way of expressing an exponential form. Now here, let a be any positive real number other than 1 and y is equal to a power x. Then x is called the logarithm of y to the base a and is denoted by x is equal to log y to base a. So this is the exponential form of a number and this is a logarithmic form of a number. So when we say y is equal to a power x, then x is nothing but log y to base a. So which is called the exponential form and this is called the logarithm form. Now anything to power 0 will be considered as 1. So if we express this in terms of logarithm, we know that y is equal to a power x. So which means x is equal to log y to base a. So here y is 1 and a you have here. So x value is 0 here. So if we express a to the power 0 is equal to 1 in the log form, then it is log 1 to base a which is equal to 0. So this base may be anything. This base may be any real number. So therefore, log value of 1 to any base is always equal to 0. Now here, if a is non-zero real number, then a power 1 is equal to a. So log a to base a is equal to 1. So here clearly y and x value are same. So therefore, log a to the same base. That means log of any value to the same base is equal to 1. For example, log 2 to base 2 will be equal to 1. Log x to base x is equal to 1. So the log of the value with the same base is always equal to 1 and log of 1 to base any real number will be equal to 0. Now let's see the laws of logarithm. The very first law says log of mn to base a can be written as log m to base a plus log n to base a. For example, if we write log of 2 into 3, then this can be written in the form of log 2 plus log 3. Next, second law says log m by n to base a can be written as log m to base a minus log n to base a. We need to learn this property from either side. So we can convert left hand side to the right hand side and vice versa here. Next, the third law says log m power n to base a. If you have any exponential form with the logarithm, then n will be written as a whole number. So it is written as n into log m to base a. Next, fourth law is a change of base. So change of base means suppose if you have a number in the form of log 3 to base 2, then we can write this as in the form of log 3 divided by log 2 by making a common base. Let it be some constant k. So like this, we can also write the number and the base separately using log in the form of a quotient form by taking a common base here. So you can clearly see the chorales which is used from the theorem or laws of logarithm. Log a to base b can be written as log a to base a, log b to base c. We know that log a to base a can be written as 1 because log of any value to the same base is equal to 1. So this is in the form of 1 by log a to b. Suppose we have log a to base b, log b to base c, then we can write this as in the form of log a to base c. If we expand this, log a to base b can be written as log a by log b by making some constant as a base. And similarly here, log b to base c, that can also be written as log b to base k, log c to base k. So clearly these two get cancels. We will get log a by log c, which can be written as log a to base c. So now we have learned how to express an exponential form to logarithm form, logarithm to exponential form, and also the laws of logarithm. Now we'll take few problems. Express each of the following in exponential form. So we have log 125 to base 5 is equal to 3. If we express this in an exponential form, suppose log y to base a is equal to x means, remember, a to the power x will be equal to y. So this is the exponential form. So this can be written as 5 cube is equal to 125. Next. Log 0.01 to base 10 is equal to minus 2. So this can be written as 10 to the power minus 2 is equal to 0.01. Next. So now here express the exponential form to the logarithm form. So we know that a power x is equal to y means we can write it as log y to base a is equal to x. So now we have 5 to the power minus 2 is equal to 0.04. So I can write it as log 0.04 to base 5 is equal to minus 2. Next. 3 cube is equal to 27. So we can write this as log 27 to base 3 is equal to 3. Next. Solve for x. So here the x value is unknown. Using laws of logarithms, we will find the values of x. Now here log 2. So here square root of 32 is 32 to the power 1 by 2 is equal to x. Using the third law, log of m power n can be written as n log m. So I'll write this as half log 32 to base 2 is equal to x. Now half log 32 can be written as 2 to the power 5, 2 is equal to x. Again using the third law here, I can write this as 5 log 2 to base 2 is equal to x. Now this becomes 5 by 2. We know that log of the value with the same base is equal to 1. So this is equal to x. So therefore the value of x is 5 by 2. Next. Log x to base cube root of 5 is equal to 6. So I can write this as cube root of 5 whole power 6 is equal to x. I'll first convert this in the exponential form. So cube root of 5 whole power 6 is equal to x. I can write this as 5 to the power 1 by 3 whole power 6 is equal to x. So index form of cube root is 1 by 3. Now using the laws of exponents, we have two powers for the same base. We can multiply them. 3 ones are, 3 twos are. So it becomes 5 square. So 25. So therefore the value of x here is 25. Next. Log 625 to base x is equal to 4. Let us convert this into exponential form. We will get x power 4 is equal to 625. We know that 625 can be written as 5 to the power 4. Now since the power are same, we can equate the base. So therefore x is equal to 5. Next. Find the value of log of square root of 9 by 4 minus log of 3 by 2. So here this can be written as log of 9, I'll write it as 3, 2 instead of 4 whole square I'll take. So 3 by 2 whole square is nothing but 9 by 4. We have a square root here. A square root can be written as 1 by 2 in the index form. So now this is log 3 by 2. So 2 get cancels. We will get log 3 by 2 minus log 3 by 2. So we know that using the log value, log m minus log n can be written as log m by n. So we can write this as log 3 by 2 divided by 3 by 2. So which gives you the value of log 1, which is 0. So here also you can directly cancel and write it as 0. So here with the cancellation, and here using the property of log. Next, prove that log 9 by 5 plus log 15 by 9 minus log 3 by 2 is equal to log 2. Now here, in the first case, this is in the form of log m plus log n, which can be written as log m into n. So 9 by 5 into 15 by 9 minus log 3 by 2. We can cancel here, 5 ones are, 5 threes are, 9 get cancels. Now we got log 3 minus log 3 by 2. Now here we have, this is in the form of log m minus log n, which can be written as log m by n. So this can be written as log 3 divided by 3 by 2. 3 get cancels. So 2 can be shifted to numerator, hence the value is log 2. Next question. Prove that log a square to base b square, log b square to base c square, log c square to base a square is equal to 1. So I'll consider only the left hand side. So here, using the change of base concept, I can write this as log a square by log b square to some common base k into log b square divided by log c square with the common base k and log c square divided by log a square with the common base k. We can cancel log a square to base k, log b square to base k, log c square to base k. So which is equal to 1, that is the right hand side. Next question. If x is equal to log a to base 2a, y is equal to log 2a to base 3a, z is equal to log 3a to base 4a, show that x, y, z plus 1 is equal to 2yz. Now first let us take the left hand side of the equation, that is x, y, z plus 1. Now if I consider x here, that is log a to base 2a. Using the change of base, I'll write this as log a, log 2a to some common base here. I'll consider it as k. Next I'll write this as log 2a to base k divided by log 3a to base k into log 3a to base k log 4a to base k plus 1. So we have x into y into z plus 1. Now here we can cancel log 2a to base k, log 3a to base k. Now if we consider this in the form, then we will get log a to base k divided by log 4a to base k plus 1. I'll write this as log a to base 4a. We know that we'll get the value of 1 only when we have a value with the common base. So since the base is 4a here, I'll write 1 as log 4a to base 4a itself, because log 4a to base 4a is equal to 1. Now this is in the form of log m plus log n with the same base. So therefore I can write this as log m into n, which is 4a into a to the base 4a. Now 4a into a becomes 4a square. So therefore here log 4a square to the base 4a. Now log 4a can also be written as log 2a whole square to the base 4a. So we have this in the form of m power n, which can be written as n into log m. So that is log 2a to base 4a. Now let me keep 2 here. Here I'll separate this as log 2a by log 4a. And this can be written as 2 into log. Here I need y and z. To need y and z, I need 3a once in the numerator and once in the denominator. So I'll write this as log 2a by log 3a to some base constant k into log 3a by log 4a to some common base k. Now clearly this is in the form of 2 into y into z. So that is the right hand side. Next, Prove that log 8 to base 4, log 32 base 2, log 4 to 16, log 4 to base 16 is equal to 15 by 4. Now let me consider the LHS. I'll write this using the change of base, log 8 by log 4 into log 32 by log 2 into log 4 by log 16. We know all of them are multiples of 2. So therefore I can write 8 as log 2 cube and 4 as log 2 square. And here I can write this as 2 power 5 and this as log 2. And here again log 2 square divided by log 2 power 4. Clearly I can cancel this. Now with the remaining I can write this as 3 log 2 into 5 log 2 divided by log 2 into 1 by 4 log 2. We can cancel log 2, log 2, log 2, log 2. Remaining is 3 into 5, which is 15 divided by 4. So that is the right hand side. So this is how we will use the properties of logarithm when simplifying the problems. I'll meet you in the next session. Until then, keep watching, keep learning and keep exploring. Thank you.